All right. What's up, guys? How you doing? All right. So it's gonna be a little bit more quiet this time. As most of you may have seen, streaming services are starting to put out warnings about copyrighted materials. So not gonna be able to play any music. Mostly because I don't want to have to re-record this stuff again. This is going to be a lot of stuff to have to re-record if it gets torn down, just because I'm playing a little bit of background music that should be free to stream. So, in any case, I do apologize about that. It's going to be that way as we move forward. But in any case, let's get started. All right. So this time we're going to do something quite different here, right? 1 second here. I'll make sure things are configured correctly. All right, cool. Okay, so we're going to move into object-oriented programming, and that's actually a pretty important topic, and it's basically the foundation of the future of your programming endeavors. Unless you just want to be a script kiddie, which is perfectly fine. Scripting is awesome. There's a lot of cool things you can do really quickly. But the real power is being able to design extensible software solutions that work well with other systems. And there's a lot of really cool things you can do with it. So let's kind of dive in here. So, all right. So I think I may have touched on it a little bit before, but if not, I want to go over again what a class is and what its structure. So first, I'm going to, do my traditional Blackboard comment section, and this time the Blackboard is going to have a lot more actual code. So I want to show you the structure of a class first, just like I showed you the structures of loops. Okay, so basically what you do is you have class. Okay, and what I'm going to do is I'm going to put these in double quotes so you know things that are more dynamic, and I'll explain that in a second. But so I'm going to put class name here, right? So that means that class name could be anything. It could be any arbitrary name that you use as long as it's a valid valid sequence of characters and numbers. Okay, so then we basically have something like that. Looks like a function body, right? But it's called a class body here. Okay, and so inside the class, and we're gonna indent. I'm gonna indent 4, just like we would with loops. And the first section is we're gonna declare instance variables. Now, what is an instance? Well, when you're dealing with classes, it's basically you're creating what's called a class definition, and then you're going to create instances of that class. So you could make a class called dog, right? And then you could just create 100 dogs. Each one of those dogs is its own instance of a dog. Okay, its type is dog. Like the class definition is of type dog, and then you're creating like 100 different instances of that dog, and then you can set maybe, I don't know, the color of one to be this and the color of another one to be that. And because they're instances of the dog, right, they both are going to have different values. So you can independently change those values. And so you can pass around, I don't know, 1,000 dogs, right? And in a more practical explanation, imagine if you were dealing with records from a database and you just retrieved a bunch of, I don't know, like purchase orders, right? And each one of those purchase orders is an instance of a purchase order, and the purchase order class has all of the information that would determine what makes up a purchase order. So there are two different things: what the properties of a purchase order is, like how much something was purchased for, the item ID it was associated with, the description, the timestamp, the currency, all kinds of things. And then there's actual operations that you can do. So you can actually call actions on classes that manipulate the internal data or the properties of that class. So the properties of that, or in another case, instance variables, right, are what make up the data inside that class itself. Okay, and every instance that you create of that type of class will have its own data. its own individual subsection of data. So you'll have your data blob here, data blob here, data blob here for like 3 different class objects. Okay, so you'd basically define a type and then variable name 1, right? And then again, type, and then variable name 2. Okay? It's pretty simple. It's just like we were declaring variables before, but instead of having them being declared just arbitrarily in our codes somewhere, like we're just putting them in this main function, now we're putting it inside of a class. Okay? No different. No different. And you can have as many of these as you want. The only thing to keep in mind is that the more stuff you put in a class, the more memory it takes to create a class of that type. Okay? And so you really want to be careful that you separate your objects into bite-sized pieces. So you don't want your objects to be too large, because if they become super large, then they just become unmanageable. It's harder to change the code later if things have to change. So there's some design decisions that you'll end up having to make at some point in order to reduce the complexity of your objects. We're not going to talk about that now. That's more of the design principles that we'll do after we learn how to use a programming language. Okay. So anyway, those are your instance variables. And then we're going to have over here, we're going to declare some methods, right? So this is a method, and we're going to say it returns a type, right? So let's actually call that the return type. Okay. And then we're going to call method name 1, right? And then inside parentheses, we have parameters, okay? And then this is the body of method, okay? Now, we're just going to make 3 of these, right? But actually what we'll do is, just because I want you to kind of have the same thing you saw up here, right? Cool. So you can have method name n. So you can have one too many methods, just like you can have one too many variables. And just so you know, these methods don't map directly on a one-to-one basis to these variables. They're not intrinsically tied to the number of variables that you have. These methods may or may not act on the data that's in here, okay? These methods are kind of arbitrary and can do whatever you want, provided you have access to the data that they require. You could even take a class, one object, and you could say one of the parameters is that type of object. And so you could actually call a function on an object that takes in another object, okay? And that's getting into some advanced design principles, design patterns, where you can do some really cool stuff. Again, we won't do that now, but I'll just say that parameters can be any type of object, whether it's, you know, one of your raw objects like an integer, a boolean, a string, a double float, etc., or it could be a complex object like a purchase record, a dog, a cat, whatever you want it to be. Same for return type. That can be any type of object as well. Okay, and your method names, any name you want, right? Variable names, any name you want. There are some restrictions. I may or may not go into that. Just a lot of those you'll find out by trial and error. You'll be like, oh, I can't start it with a number. Okay, but you know, it's not really that complicated. You'll get it as you go. That's details that probably don't need to be talked about because you'll stumble, fix the problem, and move on. Programming has a lot of that stuff. But anyway, so this is the structure. The only real thing here that matters is that you call it a class. Everything else is kind of arbitrary, right? You can fill it in with whatever you want, and that's where you kind of design it out the way you want it to be. Okay, so one other thing to note here is that, you know, in our previous examples, right? Like, let's just go over here to like continue demo. We had this, right? and we had a main function. Okay, so we have a class, and in it we had a static function called main. Okay, so far we've only been using filling out a function that's part of a class like this. Okay, but now we're going to get into actually designing the class itself and being able to do some things. So we might be doing some things in main. In certain examples we'll have a main function, but by and large we're going to be keeping our main function very tiny, because I want you to see what it's like to reduce the code for other people that want to use your stuff, because you're essentially going to end up building code that other people will eventually use. And you want the way that you use your code to be simple and really nicely designed and just really, really easy, so that somebody can look at it and read about the documentation and say, oh, I know exactly what this does, rather than have to scratch their head because it's just really complicated or the naming doesn't make sense. So when you're writing things like classes, especially for things that are public methods, and that's where we go back to the use of this word public here versus private that you saw at one of the first lectures. Private functions are less necessary to be named well, because nobody outside of your own internal developers are going to see those functions. So you probably want to still name things nicely for them. But when you're dealing with external customers that you might sell your code to, they're going to use the public methods on your classes, and you want those to be exactly what you mean them to be. Like, so if you're saying you have a calculator object and you're going to add two numbers, don't call it plus. Why would you do that? Just call it add, right? Add, subtract, multiply, divide. Like, you want to keep it simple so other people can look at it and say, oh, I know exactly. It's a calculator.add. Okay, cool. Calculators can add. Makes sense to me. Calculators don't plus. Like, that's where verbiage comes in, right? Using your own English language in the programming language to convey the thoughts that you have about the meaning of your code. Okay, and that's just as important as being able to write code. Okay, naming is hard, so start to kind of get ideas for nice ways of naming your code as you go. Get used to that. Okay, cool. All right, so okay, so I'm going to go over here to this handy dandy thing here called the vehicle demo. All right. I think I can do this. Yeah, I think I can. So what I'm going to do is I'm going to add some space here. So actually I'm going to do it above this, right? So up here, I'm going to, nope, I changed my mind. I'm going to keep it consolidated because it's all part of the same demo. So we're going to create a class, okay? So I'm going to call it class vehicle, okay? So the class keyword and then the name vehicle, and then we make just like a function body, but a class body, okay? Cool. Oh, one more thing I want to denote here. When you call a method on a class, you're going to do object dot method, okay? And this could be parameters, right? Or call it, or let's see, accessing a member on a class, object dot member variable. Okay, we'll call it member variable. Cool, and that's how you do it. Now, I'll tell you right now that generally speaking, you don't want to make your properties of your class public for the sake of this particular example. We're going to go ahead and make them public because I just want to show you simple stuff. We're going to talk about the pros and cons of this later, but just be aware that some of this might change. You can certainly do it if you want. There are better ways. So it's one of those little, like, keep it up here in the back of your head as we do this, that what we're learning is going to change a slight tiny bit to be better practice or better programming principles later on. All right, cool. So we got a class vehicle, and I'm going to make 3 member variables or instance variables here. Right? I'm going to make an integer called passengers, right? And this is going to be obviously the number of passengers in the vehicle. We're also going to say, all right, we're going to add a fuel cap. Okay, cool. So this is that's the fuel capacity. All right, fuel capacity, and we'll make it in gallons, right? Make it super simple. And then I want to know the miles per gallon, right? So this is the fuel consumption in miles per gallon. Awesome. Okay. So basically, this allows you to define a vehicle with this data internally. Okay. All right. So what I'm going to do here is in main, I think this will work fine. Pretty sure it will. I might have to make that a public class vehicle, but we'll see. But I want to create an instance of a vehicle. Okay. Now, first off, when I do that, all of these, because we're in Java, this is not true for languages like C++, but for languages like Java, and I'm fairly certain of this, these will get defaulted to 0. I'm not going to do it now, but I would highly recommend getting into the habit of manually initializing your variables to 0, right? That's always a good practice because then you know what they are, and there's no way that when you create one of these vehicle objects that they won't be those values, right? It's better to be on the know than on the unknown. If you can, of course. Especially in programming when things can go crazy real quick. All right, so let's create a vehicle. So just like we would create an integer and then name it, we're going to create a vehicle and we're going to name it. So if I can spell, I'm going to create a minivan. Yeah, sweet, minivan. And then we're going to say equals. Okay, now how do you do this, right? Because like before we would just say like 0 or like my string, right? My string. Or, you know, like false, right? Right? But that's not how we do that here, okay? So this is how you create a vehicle object, okay? So there's a keyword that's reserved in Java called new, okay? Notice how it's orange. What you're saying, and you don't have to do this for integers. I think you can. I just don't think there's any point to it. But what it does is it says, okay, computer, I want to allocate enough memory for my vehicle object, right? And what that's effectively saying is that because the vehicle object has 3 integers, that it's at least going to need as much memory as 3 integers takes in. And I think those are 32-bit, if I remember correctly. So you're going to be looking at 96 bits, but which is that's 12 bytes. And then there's also something called, well, there's a lot more that goes on with this. There's a virtual function table. There's all kinds of additional fluff that gets added in because it's a class. I don't know the size of a Java class without taking into account the data members, but for the purposes of this, you don't have to care. You just have to know that the computer is basically going, or the compiler needs to know, actually the program, the VM, needs to know how much memory to allocate for an object of type vehicle. And it is whatever is the vehicle class size plus the data values within that, okay? And because of that, you have to use the new keyword, right? Because it's not like, oh, I need an int. An int's always 4 bytes, right? You don't say that because an int is not always 4, an int's always 4 bytes. But this vehicle, you could come in later and be like, oh, I'm going to add a boolean that says, jacked my program up, right? Thing is, you won't be jacking your program up because as soon as you use new, it's going to just take that into account the next time the program runs. It'll be like, oh, okay, cool. There's no predefined listing of what a vehicle is in the compiler or anywhere in the Java language. It's up to you to define that. So you won't get screwed. So you use new because it's a custom object that you have defined. So you say new vehicle, okay? And then you use an open and closed parenthesis. Now, there are more complex ways to call this default method, and I'll explain what this is in a second. For now, this is how it works. I will teach you other ways to do it later. We'll get there. But you basically say new, the name of the object, and then an open and closed parenthesis, okay? This is called the constructor, okay? A constructor is a function on a class that always exists. You are allowed to define it manually. You are allowed to define different versions of that constructor in case you want to create your object in different ways. It is not a method. It is a constructor. It's different. What happens is when the object is first created, the very first thing that's called is this constructor right here. Okay? When this constructor gets called, it's when the object is created. Okay? Construct the object, right? You create the object, it is constructed, the constructor, okay? So this is the very first thing that happens. To give you an idea of what it looks like, it looks something like this. You are allowed to define it manually like this. And you're allowed to, like, say, I don't know, you want to print something? I'm creating my vehicle. Okay? So this is automatically created, but for example purposes, here's us defining it ourselves. Okay? And remember, that's automatically created. Okay? But there it is, okay? Cool. And now we actually have overloaded the constructor. This is called overloading. You've now said, I don't want to use the default version of the constructor. I want to have my own that prints a message that says, I've created the vehicle. All right? Now, we're going to get into this later, so I'm not going to confuse you. I just wanted you to see what it is that this is calling. Just remember to do this. Okay? Now you know a little bit of why. I'm not going to add that in here. You'll come back to that later. And we'll play around with that. Okay? So you create your minivan, all right? And let's see. What do I want to do here? I want to be able to calculate the range. The range that my minivan can travel. Okay? So we're just going to do some simple arithmetic. So the first thing I want to do here is I want to assign values to fields in the minivan object, okay? So if you remember from the blackboard over here, we can say object.memberVariable, okay? So let's go ahead and do that. Let's say vehicle dot, guess you can't. Guess we would have to do the public keyword, huh? Okay, let's make that public. Of course, you also have to make this public too, don't you? Huh. Okay, well, we're going to continue coding as if this just works. There might be a problem here, and it might be because it's not in its own file. But let's just keep going. We'll solve that problem if we have to. But we know we want to set the number of passengers, right? So let's just copy this, right? And then we will set the passengers to 7 passengers. We're going to set the fuel cap. Okay, and we're going to set it to 16 gallons, okay? And then we're going to say that this vehicle, that its miles per gallon is 21, okay? And then we want to compute the range, assuming a full tank of gas, right? And we're going to say the range, right, is equal to, okay, there they are. Now it's picking them up. Cool. So it's fuel cap. And actually, I want to get rid of this public keyword, see if that matters too. So the fuel capacity multiplied by the minivan's miles per gallon. Okay, so it's that simple. You just basically do dot and the member variable name. And now we've gotten the range. Now we can actually, since we've captured that information, we can say minivan can carry, and then we're going to say minivan passengers, and then with a range of range. Okay? All right, so we've created a vehicle using its constructor, using the new keyword. We've assigned the number of passengers, the fuel capacity, and the miles per gallon. We have then calculated the range, which was the product of the fuel capacity and the miles per gallon, and then we've taken that captured range, calculated range, and we have printed that out to the screen. Okay, so a simple class and some operations on it to show you how you can manipulate data in that object. Okay, so let's go over here. Let's do the old Java compile. Cannot find symbol. Ah, because I called it minivan, didn't I? Yeah. It's all right. All right, let's try that now. Can't find main method. Can't find main method. Is it because I... There it is. That's weird. Apparently you have to have this after the main. That's strange, isn't it? Anyway, let's run that again with a clear screen, and it says minivan can carry 7 with a range of 336. And sure enough, 16 times 21 should be 336. I'm just going to assume that that's correct. I don't want to be monkeying around with that. So yeah, that's basically how you do that, right? Cool. So that's a class. So, you know, if you are comparing to our class details of what we're going to go over today, you know, basically, and let me just head over here real quick. I want to. Okay, so we're supposed to go over how to define a class and how to create a class and how to assign classes to one another. Okay, so we've already done the first two, right? We've defined a class called vehicle, we've created one, and we've manipulated it. And now we're going to show you how to actually assign these vehicles to each other, okay? So I'm going to go over here, and I might be doing some copying and pasting to save some time. Also, this might be a short lesson. I don't want to overload you with this, right? I want to kind of just give you some basic info about classes. I want you to have like 3 days to think about it and to, you know, to like think about that in your head. And then I want you to come back and then work with it some more. You know, do some examples on your own. Just make your own class. Do some operations. Just do the same thing I've done over here. Make a carrot class. Carrot has calories. You know, it also has things you can dip it in. I don't know. You can figure out some stuff that you want to add as member variables, and then go ahead and just, you know, write some code, right? Get used to the idea of a class. Classes get very complex very quickly. This is probably one of the simplest versions of a class that you can have. All right, so we're going to actually grab this vehicle right over here, okay? Same thing. Cool. All right. So let's also grab this declaration here for the vehicle, the minivan. And we're going to do another one, right? And we're going to call it a sports car, right? Okay. So we're going to say, remember, minivan and sports car are I think a better way to say that is refer to two separate objects, okay? So just like before, we're gonna, calculate the range. We're gonna do it for two different objects, right? All right, so let's grab this. We're going to use the same thing. Okay, let's copy that again and just change some values. Here, let's change that spelling because I noticed there was a... Okay, cool. We're going to change this to be sports car. All right. And then we're going to change these values to something different so it's not all the same, right? It's going to be completely different. Let's grab computer the range. All right. So let's grab this. So we computed the range for the minivan. Okay. And then we're going to do the same thing for the sports car, right? Now notice how it's just nicely telling you where all the variables are. Voila. Very quick code. Very fast code. So this one tells us the minivan. This one tells us the sports car. And we're just going to copy paste. And make this one range 1 and range 2. And then we're good. And so, okay, just to reiterate what's going on here, and what this does. I'm effectively showing you that each of these vehicle objects are instances of a vehicle, but that they have different data. So that block of memory that's allocated when you say new vehicle, that block of memory for the minivan is a different block of memory than the sports car. And so you can change one, not the other, or both of them, and they're both going to reflect different states of the data values, okay? So let's go ahead. What's the name of that? Oh, two vehicles. Hey, look at that. I don't even have to do Java compile. Nice. Okay, we'll skip that. Okay, what is going on here? Something isn't right. Aha, because I had a bug. Sorry about that. Cool. Minivan can carry, well, let's do this. Let's move this down here. All right. So the minivan can carry 7. The sports car can carry 2. Minivan's fuel its range is 16 times 21, which is 336. The sports car range is 14 times 12, which is 144 plus 24, 168. 12 times 12, 12 times 12, 144, plus 12 times 2, 24. Yeah. So as you can see, all the information is reflected, and you have two different states of data. Cool. Right? So there's really nothing unique there that I've taught you. I've just showed you that it is in fact working the way it was originally explained. And this is where the power comes in, because you can have a class that's a generic class that does a bunch of stuff and you can reuse it. The point of code is to be able to reuse your code, right? Okay. Now, the rest of our examples, correct me if I'm wrong. Yeah, rest of our examples are going to happen within the Blackboard, okay? So what we're going to do is add some space in here, right? Now, I want to create, well, to do this, I'm going to grab this class, vehicle class, right? We're going to take that, and we're going to put that directly in the Blackboard here, okay? And then we're going to say vehicle car 1, and we're going to say it's a new vehicle. Awesome. Same stuff we've done before, okay? Actually, no, we're not going to do that yet. Psych. I want to show you the concept of a reference before we go into doing an example. This will give you a little bit more clarity on the issue. So remember how we had a minivan? Well, before we were doing new vehicle, right? But we're not going to do that. Okay, we're just going to do this. Okay. Now, what do I mean by that? Okay, what that means is that is a variable that is supposed to point to a vehicle. Okay. Now, there is no data backing this variable. Okay, this variable is not. It's basically null. Null is a special value that says nothing is assigned to this. There's nothing. If you try to do something with it, it's going to blow up. Okay? It's called null. Very special. Okay? Okay. This will be null until it's assigned. This, if you try to do anything with this before you use it, it will blow up in your face. Okay? You have been warned. You will see this time and time again. I do as well. But important is that you can create a variable that is not pointing to anything, and then you can worry about getting it assigned later. In fact, I can do it right now. I can say, okay, I'm going to take my minivan variable, and then I'm going to create a new vehicle. Okay? I'm effectively doing the same thing I did before, except now I'm showing you that I can create a variable and allocate the object to it later. Okay? Cool? That is important. So here's what I'm going to say. I'm going to take my handy if control. I'm going to say if minivan equals null, I'm going to say the minivan is null. Okay? Then after I assign it, I'm going to say if it's not equal to null, and I'm going to say it's no longer null. I think this works. Pretty sure it does. Let's find out. Let's run the blackboard. Oh, might help if I use semicolons. Cannot find symbol. Oh, what am I doing here? That's right. I was doing Python earlier and I completely This is what I get for using multiple languages a day. Yep, we're going to use system out print line. Cool. What is going on now? Ah, yes. It's telling me that it might not be initialized because it actually isn't initialized, right? So this does nothing because the compiler already told you don't do that, right? So we know that this is not initialized. The compiler just kind of short-circuited you. So not good, right? But I'll run it like that, which then you should absolutely see that second one. The minivan is no longer null, right? So whenever you create a variable, I want you to always do that. I want you to always do that. Okay? You don't have to. You should. Okay, cool. Anyway, you've created a minivan. Now I want to show assigning. So assignment of class variables. If I can, once again, if I can type. Okay, cool. Again, this is not rocket science. It's really easy. But I want to show you something about this that's going to be very important for you to know. So I'm going to create a vehicle. I'm called car1. All right. Let's go ahead and create that vehicle. Cool. There's my first one. I'm going to make another vehicle called car2. except this time I'm going to set it to car1. Okay. I've created a vehicle called car1. Then I've created a variable called car2, and I've set it equal to the previous thing I created. Okay. Now, I'm going to put that there because I'm going to write a comment there later about what's actually happening here, because I'm going to ask you some questions and I'm going to have you think about this while I discuss it afterwards. So I'm going to say car1 dot miles per gallon equals 26. Cool. I've set car1's miles per gallon. I have not set car2's miles per gallon. Now I want to print out car1's miles per gallon, and then I want to print out car2 miles per gallon. And I want to ask you guys, what do you think is going to happen there? Okay. And the reason I ask you that is because I want you to think about this for a second. You got two variables here, car1 and car2. This is a reference to an object. Okay. So it's not the same as an integer. It is a reference to a data blob. This creates the data blob. This references the data blob. So if I create another reference to a data blob and I say that it refers to the other previous reference of the data blob, then the data blob should trickle its way backward to the original data blob, right? And this is basically called a pointer. In Java, we call it references. In C++, it's generally called a pointer. And everybody goes, oh my gosh, pointers. It's most of the time it's where people fall over in programming. And it is a tricky thing to get your head wrapped around. But it is not terribly difficult once you understand exactly what's going on here. A classic analogy that people use is a mailbox, right? Like, the mailbox that belongs to your apartment or house, okay, is always the same address no matter who lives there, okay? So the data that's backing it, the data would be basically whoever is occupying that apartment or house at any given time. The reference, okay, it is like the mailbox, okay, sort of. So people move in and out of apartments all the time. What that means is your data is shifting around and you can point to different data, okay? So you can basically point your mailbox to whatever data you want at the time. Okay? So if another family were to move into that house, you would point the mailbox to that family instead. You would say, now that's the family that this mailbox belongs to. Okay? I'll see if I can come up with a better analogy for that later. But essentially, this creates the data block of, you know, all your integer, strings, booleans, other your properties. And this basically says, I'm talking about that data. Okay? But if you create another reference variable, you can say, I also want to talk about that data. So when you change you use the reference to car1 and change that data, you're going to change car2 because car2 references car1, which references the data. That's important, okay? Because it means you can have two reference variables that point to the same block of data, right? And because of that, when you change the data, it changes for both. And that's just really, really important to know for potential bugs that may pop up. You might be like, oh, I'm changing the data, but it's changing something else. And You're probably referencing it using a member variable and you didn't know you were doing that. So let's run this, right? Cool. They're both 26. They're both 26. Okay? Because car2 points to car1, which points to this data block. Awesome. One last example. So we're going to do car3. Okay. And then we're going to do car2. And we're going to say it's car1. Oh, wait. You know what? The heck with it. We're just going to continue on this. I want to fill in this comment. This will change car2 as well. Okay. But I want to add another. I'm just going to piggyback off of what's already here. Makes more sense. Just make a new come on. A new vehicle. Okay. And then after this other example here, right? We're going to leave that comment out, the printing. And I'm going to just say car2 equals car3. Okay? Now, I'm not going to print anything out. I'm going to leave this up to you. But now car2 and car3 refer to the same object. Okay, so we have car1 and car3, which point to literal data blocks. And then we have said car2 originally was pointing to 1, but now we can change it. We can basically shift it and say, now we're pointing to that guy, which points to someone else, okay? So you can kind of flip a switch, right? That's important because now if you were to change car1 again and print out the values, right? And let's try that, right? Let's do car1. So let's go ahead and do this. And then we're going to say, car1 miles per gallon equals 10, right? And then print out again. So, oh, come on. Okay. So the first time it updated car1 and car2. This time, since car2 is now car3, car2 should still stay 26. Actually, what will that print out? Car2. Ooh, it might be 0. It might be 0 because car3 is pointing to a data block that has not been set. So let's try that. Yeah, there we go. All right. So the second time we run it, car1 has indeed been changed to 10, but car2 is pointing to car3, which hasn't been initialized to any values, so it defaults to 0. Okay? All right. So play around with this stuff, okay? We're going to end now, and I'm going to let you guys kind of mull that over because there's a bunch of concepts in there. Not terribly complicated, but they are foundational, and you really should spend some time thinking about them. Try creating some classes. Try setting them to each other. Try, reassigning member variables, reassigning reference variables like this to other class objects, and then playing around with them, swapping them, and printing out values and see what happens, just to kind of wrap your head around it and to make sure that your expectations are correct. The quicker that you get a handle on this, the easier that the subsequent lessons will become. We are going to start kind of going into some more and more crazy things around classes and objects. And it gets more complex, right? There are objects out there that do some crazy things. There's a list object that allows you to create a container that's a list of objects in a row, and so you can add objects to the back, you can push them, insert them into the front, you can insert them at arbitrary locations within the list, you can sort the list, you can do all kinds of crazy things that are really good for data manipulation. But you have to understand this first. So in any case, that's it for today. So yeah, I'll see you guys next class. See ya.